Hello everyone. In the last video we have seen the definition of even and odd permutation. Now in this video we are going to see two important theorems. So the first theorem is the number of permutations in Sn the number of permutations in Sn is n factorial, or the cardinality of Sn is n factorial. We have already seen this in S3, that the cardinality of S3 is 6, that is 3 factorial. So in general, the number of elements in Sn should be n factorial. So let us see the proof. So let capital A be the set of numbers 1, 2, 3, 4, 5, 6, 7 up to n. And what was Sn? Sn is set of permutations on A. Now what is the meaning of permutation on A? Permutations are nothing but a bijection, that is each permutation is a bijection. Bijection means a function which is 1, 1 and on 2 is a bijection from A to A. Hence, images of each element in A can be selected in following manner. So to find a permutation on A means we have to see the images of elements of A under that permutation. So how we will select the images? So for image of 1 there are n choices. So if you are saying that you want to choose a permutation alpha, and the image of 1 under alpha, for image of 1 under alpha you have n choices. You can select alpha of 1 as 1, alpha of 1 as 2 also, alpha of 1 as 3 also. Okay, so for image of 1 there are n choices. Once this choice is fixed for 1, then for image of 2 there are n minus 1 choices, because already one choice is fixed for 1. Then for image of 3 there will remain n minus 2 choices, because already 2 choices are fixed for 1 and 2. So continuing in this manner, so on. So let me write that part here. Continuing in this manner, for image of n minus 1, there are 2 choices. For 3 there are n minus 2 choices, so for n minus 1 there are 2 choices. And for image of the last element of A, that is image of n, there remains only one choice. There is one choice. For image of A, there is one choice. Image of N, there is one choice, and therefore the total number of ways for writing a permutation for writing a permutation on A is equal to, for the first element of A there are n choices, then for the second element n minus 1 choices, n minus 2 choices, then 2 choices, and then only one choice. So thus the number of ways of selecting one permutation on A is n factorial, and hence total number of permutations in Sn, that is cardinality of Sn, is n factorial. Let us see the second theorem, which is again an important theorem. So the next theorem, we have seen that that two permutations does not commute, but two disjoint cycles commute. So disjoint cycles in Sn, disjoint cycles in Sn commute. In other words, if alpha is equal to the cycle A1, A2, AM, and beta is equal to the cycle B1, B2, BK. These are the two cycles which are disjoint, have no element in common, have no common element. If alpha and beta have no common element, then disjoint cycles commute means we have to show that alpha beta is equal to beta alpha. So let me write the proof by rubbing all this. We have to show that these two cycles commute with each other. So the proof, we consider the set A 1, 2, 3 to n, and Sn is set of permutations on A. Alpha is equal to A1, A2, AM, and beta is equal to B1, B2, BK are disjoint cycles in Sn. This is given to us. So what we have to show? We have to show alpha beta is equal to beta alpha. That is, we have to show that alpha beta of x, alpha beta applied on x, must be equal to beta alpha applied on x for all x belonging to A. For every element of the set A, alpha beta of x is equal to beta alpha of x. This we have to show. So we rewrite A as the set A1, A2, AM, b1, b2, bk, that is the elements of alpha, then the elements of beta, and then the elements which are not there in these two cycles, alpha and beta. We call those elements as C1, C2, Cr, where C's are the elements other than elements of C's are the elements of A other than elements of alpha and beta. Means these elements Ci's are not there in alpha and beta. Now for each element of A, we have to show that alpha beta of x is equal to beta alpha of x. So let us consider the first element from AI's. So if x is equal to AI belonging to the set A1, A2, Am, then let us see the action of alpha beta on x. So alpha beta of AI. The meaning will be alpha of beta of AI. Now, as the element AI is not present in the cycle beta, so beta will fix this element. AI will map to itself only under beta. So this will give you beta of AI is equal to AI. So you will get alpha of AI since beta of AI is equal to AI. And alpha is taking AI to AI plus 1. So alpha of AI is AI plus 1. So alpha beta of AI is AI plus 1. Now let us see beta alpha of AI. Beta alpha of AI, that is beta of alpha of AI. Alpha is taking AI to AI plus 1, so this will give you beta of AI plus 1. But beta in beta AIs are not there, so beta will fix AIs and therefore it will remain same AI plus 1. So from this 1 and 2, what do we get? That alpha beta of x is equal to beta alpha of x for all x belonging to the set A1, A2, Am. Now, if x is from the set, x is any bj from the set b1, b2, bk, then let us see what is alpha beta of x. That is alpha beta of bj. So this is alpha. First apply beta on bj. Beta of bj. Bj is from the cycle beta only, so beta will map bj to bj plus 1, so this will become alpha of bj plus 1, since beta of bj is equal to bj plus 1. And because bj's are not there in the cycle alpha, so alpha will fix the elements bj's and therefore it will take bj plus 1 to bj plus 1 only, since alpha of bj plus 1 is same as bj plus 1 only. So alpha beta of x is bj plus 1. Let us give it as number 3. Now let us see what is beta alpha of x. So beta alpha, beta alpha of x, that is beta alpha of bj, which is beta of alpha of bj. Now bj is not present in alpha, so bj goes to bj itself under alpha, so it is bj only, since alpha of bj is bj only, and bj will map to bj plus 1 under beta. So beta alpha of x is equal to bj plus 1. So from 3 and 4, alpha beta of x is equal to beta alpha of x for every x belonging to the set b1, b2, bk. Now finally take x as ci's. So x is equal to ci belonging to the set c1, c2, cr. Then alpha beta of x, that is alpha beta of ci, which is alpha of beta of ci. Ci is not present in the cycle beta, so it will be fixed by beta, so it will be same as ci only. So alpha of ci, again ci is not present in the cycle alpha, so alpha will fix ci, so it will be ci only. Number 5. Let us see beta alpha of x, that is beta alpha of ci. It is beta of alpha of ci. Again, by the same reason, alpha is fixing ci, so alpha of ci will be ci only. Again, beta is fixing ci because ci is not present in beta, so beta of ci is ci only. So from 5 and 6, we observe that we get that alpha beta of x is equal to beta alpha of x for all x from C1, C2, Cr, and hence alpha beta of x is equal to beta alpha of x for all x belonging to A, and therefore alpha beta is equal to beta alpha, that is disjoint cycles commute.